Mr. Moore's math class! Hey! Okay guys, welcome to Mr. Moore's online math class. Now remember, like always, put your feet up, grab yourself a hot chocolate and a piece of paper and pen to jot down some notes, and let's get stuck straight in today's lesson. Okay guys, today we're looking at the topic called limits in respect to hybrid functions and discontinuous functions. But before we get started, let's get one thing straight. If any one of you guys have ever said Mr. Moore doesn't come through with the goods, well, you can take that back right now, because that's right, I've just gone out and I've secured an A-grade celebrity to star on our show today. So everyone, let's give her a round of applause, Miss Lindsay Lohan.
Dun 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 dun!
Lindsay, everyone! Alright guys, I know that was just a picture of Lindsay Lohan and wasn't actually the real deal, but I promise you, if you hang around, you're going to see her helping us out with the math real shortly. Okay, so what we're going to do is we're going to have a look at hybrid functions and see if the limit actually exists for them. But in order to do that, we're going to use the hybrid car, Toyota Prius, to help us out once again. So let's have a look.
The limit will exist for a given x value if for that x value the y values are approaching the same number from either side. Therefore, essentially, as long as the Toyota Prius does not drive off a cliff, the limit does exist. Let's have a look to see if the limit will exist for this hybrid function. Yes, it does, because as the x value approaches 1 from either side, the y value approaches 2. Does the limit exist for this function despite it being discontinuous at x equals 1? Well, sure, the Toyota Prius hit a pothole, but it was still able to continue driving after x equals 1, therefore the limit does exist. How about this graph? Do both functions approach the same y value at x equals 0? As you can see, the Toyota Prius has ended up in quite a bad shape after falling off a cliff and can no longer drive any further. So therefore, does the limit exist? I don't know. What do you think, Lindsay?
Anything about limits? Limits. That was the week Aaron got his haircut. Oh god, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
You're spot on. Well done, Lindsay. Because the graph does not approach the same y values at x equals 0, the limit does not exist for this function at x equals 0.
Good old Lindsay Lohan. Hey, I tell you what guys, there's no better role model out there for the youth of today than the woman you've just seen on screen. Okay, so now it's time to have a look at a couple more worked examples, so let's go.
Alright, so this question is asking us to find the limit as x approaches 1 for the function x squared minus x over x minus 1. First of all by hand, then using the calculator. So let's go through that. We'll rewrite the function. Right, so what I've done here is I've actually written the same thing out, but I've actually factorized the numerator, taking the x out as a common factor. Now we know that we cannot have 0 on the bottom, because if you divide this function by 0, it's not going to exist. You can't divide by 0. So therefore, what number for x will give us 0? Well, if we make x 1, we have 1 minus 1, which is 0. So we know that x cannot equal 1. So what we need to do is we need to finish off the rest of this. So we can have x minus 1 and x minus 1. That's going to cancel out as a common factor. So we've got the limit as x approaches 1, with these two x minus 1s cancelled out. So it's equal to x, where x cannot be equal to 1, because you cannot have 1 on the bottom, because if you have 1 minus 1, you're going to get equal to 0. Now because we want to find the limit as x approaches 1, all we need to do is substitute 1 in for this, for x. So if you substitute 1 in for x, you're going to get the limit approaches 1. Now how does this look? Well, this function here looks like f of x is equal to x. So it looks like the same function as a y equals x graph. Alright, but it's discontinuous at the point 1, 1. Alright, that is the x coordinate of 1, as we found out before, and the y coordinate of 1. So what we actually have is a open dot at 1, 1, and we sketch the graph of a normal y equals x graph for everything else. So once again, this looks like a normal y equals x graph, or f of x equals x graph. There's a normal straight line, alright, but it's discontinuous at the point 1, 1, because we know that the x value could not be 1, and when we substitute in the x value of 1, we got a limit of 1. Right, on the calculator now, what you need to do is you need to get into a calculator page. You then go Menu, Calculus, limit. Alright, now type in all the relevant things in the appropriate boxes. So we've got x, 1, f of x, and we have x squared minus x over x minus 1. So the limit as x approaches 1 for f of x for equals x squared minus x over x minus 1. Press enter and you get the answer of 1. Alright, this question says by first factorising the numerator, simplify the rational function f of x is equal to x squared plus 5x plus 6 over x plus 3, stating the value for which the function does not exist. Okay, so what we need to do, as the question said, is factorise it first of all. So we have f of x is equal to x squared plus 5x plus 6 over x plus 3. Alright, well let's factorise this, so that is equal to x squared plus 5x plus 6. Well, the factors of 6 that add to 5, factors of 6, 2 and 3, just 2 and 3 add to 5, 2 plus 3 does. So you've got x plus 2 and x plus 3 over x plus 3. Now what we can do is we can make these x plus 3's cancel out. So we have equals x plus 2. So f of x is equal to x plus 2, where x cannot be equal to negative 3, because if we have negative 3 up here, negative 3 plus 3 is 0, and we cannot divide by 0. So x cannot be equal to negative 3. Therefore, f of x is discontinuous at x equals negative 3. Next question says find the limit f of x as x approaches a, where a is the value of which f of x is discontinuous, basically meaning where a is equal to negative 3. Alright, so what we need to do is we need to write out this in terms of limit now. So we write the limit as x approaches negative 3, because x cannot be equal to negative 3, x plus 2 is equal to, alright, substitute negative 3 for x now, negative 3 plus 2 is going to be equal to negative 1. So the limit as x approaches negative 3 for this function here is equal to negative 1. Therefore, f of x equals x squared plus 5x plus 6 over x plus 3 is discontinuous at the point negative 3 and negative 1. Alright, so it's time for the third and final worked example for this topic, and this question says sketch the graph of the following hybrid function f of x for equals x squared for any value of x less than 1 or equal to 1, and f of x is equal to x minus 1 for any value of x greater than 1. Alright, so let's first of all sketch the graph of the x squared for any value less than 1, so we may as well find the endpoint being at 1, so we'll substitute f of x equals x squared. Therefore f of 1 is equal to 1 squared, which is equal to 1. Therefore the coordinate of the point is x equals 1, y equals 1, is at 1, 1. And this is included because of the square bracket here. So it's 1, 1 with a dot there. Alright, it's an x squared graph, so substituting 0, 0 equals 0 squared, which is equal to 0, so therefore the point 0, 0. Just touches there, and we'll substitute in, say, negative 1. Which is equal to 1, so therefore negative 1, you get 1. Come along, put that point in there. So the graph is going to look like, for the x squared graph, it's going to come down here, touch the 0, and continue its way up here, like so. Alright, sketch the second part of the graph now, so that is f of x is equal to x minus 1.
for any value greater than 1, so therefore let's substitute in the extreme value, which is 1 of course. So substituting that, f of 1 is equal to 1 minus 1, which is equal to 0, so the coordinate of that is 1, 0. Now because it's not actually touching because of the round bracket, we're going to draw an open circle. Alright, let's just enter in say 2 for example. F of 2 is equal to 2 minus 1, which is equal to 1, so therefore it goes to the coordinate 2, 1. Draw a dot here, join the line, and because it goes on forever we have a arrow going like so. Okay, so the next question has 3 parts. It wants us to find the limit as the x approaches 1 from the negative direction, as the x approaches 1 from the positive direction, and if the limit actually exists. Alright, so let's have a look at the limit of f of x as it approaches from the negative direction. So the limit as x approaches 1 from the negative direction, f of x is going to be equal to the limit as x approaches 1 for x squared, which is equal to 1 squared, which is equal to 1. Therefore, as the x value is getting closer and closer from the negative direction, the y value is getting closer and closer to 1. Alright, the second part now. Find the limit of f of x from the positive direction. So the limit as x approaches 1 from the positive direction, f of x is equal to the limit as x approaches 1 for x minus 1. Therefore we'll substitute in 1 for x minus 1, you get 1 minus 1 equals 0. So looking at the graph now, as it approaches from the positive direction, as it gets closer and closer and closer to 1 from the positive direction, you end up getting an answer of 0. Finally, the last question says, find the limit as x approaches 1 for f of x if it exists. Well, let's have a think about the Toyota Prius once again. Driving along here, if it was drove up to this point here, it of course would have to fall off a cliff in order to get to the next part of the graph. So therefore, the limit as x approaches 1 for f of x does not exist. This is because left limit does not equal right limit.
Thanks guys for tuning into the lesson on limits of discontinuous and hybrid functions. Make sure you stay tuned for the very next lesson, which is all about differentiation using first principles, okay? And like always,
Do you need my help for this one, mate?
no, I didn't today.
Say hi to your maths teacher for me.
It's okay, Jerry, I got this one. Alright, Lawsy out.